Hi and welcome to this next video in our probability series where we will look at growing our comfort and understanding with contingency tables. So let's start by giving their context and purpose. Contingency tables summarize data and are useful for representing multiple outcomes and determining the probabilities of certain events. So if we look at the following, this is a 2x2 contingency table and it represents the data of 98 learners from a school regarding the playing of sport and the playing of a musical instrument. How it works is that the numbers in each row add up to the totals on the right and the numbers in each column add up to the totals below. The overall total is then in the bottom right corner and it is both the total from the totals above as well as from the totals to its left. Having two ways to find this total helps to make sure that all your entries are in fact correct. Let's go on now to see some questions on this information. So first, let's have a look through the questions. And I recommend pausing after each to try it yourself. The key when working with data from a contingency table is to be mindful of which total you need to work with. Okay, so if a learner is chosen at random, what is the probability that A, they play an instrument? B, what is the probability that they don't play sport? C, what is the probability they play an instrument and play sport? D, what is the probability that, given that they play an instrument, they play sport? And E, what is the probability that, given that they don't play sport, they play an instrument? Okay, the solutions. For A, the probability of playing an instrument, here we find the total number of students that play an instrument, which is 40, and so to find the probability, we put 40 over the total number of students, and this simplifies to 20 over 49. Then for B, the probability that they don't play sport, we find the total that don't play sport over here, 23, and we put 23 over the total number of students, so the probability here is 23 over 98. For C, the probability of playing an instrument and sport, we can see these two parts of information, plays an instrument and plays sport, meet over here. And so we can say that the probability is 32 over 98, which then simplifies to 16 over 49. For D, the probability of playing sport, given that they play an instrument, well, here we can only consider the learners who play an instrument, and so the probability in this case is 32 over 40, which simplifies to 4/5. And then E, the probability of playing an instrument, given that they don't play sport. Again, here we are looking at a part of the information, this time those who don't play sport, and so the probability of playing an instrument is then 8 over 23. This first example was to help orientate you around a contingency table. Now we're going to move on to look at how contingency tables can be useful in determining whether events are independent or mutually exclusive. Let's consider the following contingency table, which contains information regarding a box of 20 chocolates. We can see from the table that there are white chocolates and dark chocolates, as well as chocolates with hard centers and chocolates with soft centers. The first question here is asking whether the events hard center and white chocolate are mutually exclusive, and we're asked to use the values in the table to justify our answer. Maybe pause the video for a moment here to think about what you would do. Then the second question is asking whether the events hard center and white chocolate are independent, and here we are asked to show our calculations to support our answer. Again, we suggest to pause the video so that you can give the second question a bit of thought as well. So for the first question, first, we remember that for mutually exclusive events, the probability of A and B must equal 0. So let's find the probability of chocolates with a hard center and white chocolate. And we do this by following along here for hard center and here for white chocolate, and we find where they meet. So here at 3. Also, we are considering this from the entire box of 20 chocolates. So the probability is then 3 over 20. And so we can say that therefore this probability is not 0, which means these events are not mutually exclusive. Then for question 2, we remember that for independent events, P of A and B is equal to P of A times P of B. And so we find the probability of hard center, 7 over 20, and the probability of white chocolate, 8 over 20. And if we find the product of these two, it simplifies to 7 over 50. Then if we use the table to find the probability of hard center and white chocolate, we get 3 over 20, and we can therefore conclude that these events are not independent because these two are not equal. Let's look at this example now. In a survey, 1,620 skydivers were asked if they had ever broken a limb. The results of the survey are given in this table. The results displayed in the table give information for whether they had or hadn't broken a limb and for how many years' experience they had. As you can see, there are some gaps in the information provided, and the first question asks us to calculate these gaps, the values of A, B, C, and D. Question 2 asks us to calculate the probability of choosing at random in the survey a skydiver with more than 5 years' experience who had not broken a limb. And question 3 asks, is being a skydiver with more than 5 years' experience and broken a limb independent? And we need to use calculations to motivate our answer. If you're feeling up for trying this question on your own first, then pause the video here before moving on to the solution. Well done for trying. If you did give the solution a go, let's see how you did. To find A, we look to see where our information is. There are too many unknowns in the horizontal, but fortunately there is enough info in the vertical to find A. Remember, this is the total of everything in this column, and so A is 540 minus 405, which is 135. Then we can find B by using the info in this row, 1,215 minus 405, which gives us 810 for B. Then, because we now have B's value, we can find C using the info in this column, 1,080 minus 810, which is 270. And finally, D we can find either using this column or this row. And because there are two ways to find D, finding it in both ways is a good way to check the accuracy of our calculations. Now that we have found all the information, we are ready to tackle question 2 and 3. So question 2 asked us to calculate the probability of choosing at random in the survey a skydiver with more than 5 years' experience who had not broken a limb. And so we go to the table and see where these two conditions meet. Our numerator is then 270, and we're choosing at random from all the skydivers, so our denominator is 1,620. This fraction then simplifies to a sixth. Question 3 is asking about whether these events are independent, which means we need to use the rule for independent events. And so first we find the individual probabilities. First, the probability of more than 5 years' experience, which is 405 over 1,620. And this simplifies to a quarter. And the probability of a broken limb is 540 over 1,620, and this simplifies to a third. We then find the product of these probabilities, which is a twelfth, and then separately we find the probability of more than 5 years' experience and a broken limb, which is 135 over 1,620, and this simplifies to a twelfth, which means these events are independent because these two are equal.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.